right, gentlemen, we have a guest this evening. Alice Cranker. He is the Network Systems Administrator for the Pittsburg Community Schools.
K-12.
Great. Technology Department. He's graciously agreed to come out and talk about what he does and some of the nifty tools that, some of which you've already seen, I'm sure. But I'm sure there's a few other surprises in there that you haven't. And so I thought this would be a good opportunity for you to hear from a different perspective, kind of a review of what we've talked about and what we've done over the course of the semester. And then after Mr. Cranker gets finished, then we'll kind of start talking about our discussion with regard to network security. Just as a preview, next week, your Chapter 5 homework is due. Well, as of about 5 minutes ago, your research paper should have been handed in online. I saw several of them already, looked at a few of them, and I know there's a few more still out there I haven't touched. So we'll get that turned around here in a while. Next week, just note, we will be meeting over at Names and Numbers for our final lab project, lab number 3, that will be tracing the cable, as well as finishing up a few other odds and ends, as well as give you the opportunity to ask any questions, pursue any interests in regard to our grand finale on the 11th, right? The big test. So that is a comprehensive exam. So something to look forward to, I guess. Great. With no further ado, Dallas, thank you so much for sharing some time with us. I'll try to adjust the lights the best I can. Are you going to be doing anything like
Yeah,
that?
actually, I've got some pictures and stuff online I can try to bring up.
You're wonderful. Just help yourself.
Okay. Like Al said, I'm Dallas Ryan Cranker, Network/Systems Administrator. Started about 2003 at Pittsburg Public Schools. Started as a technician, and I worked my way up. And I had a BST. I'm actually a PSU alumni, 2003. So I did PSU all 4 years, and started getting involved with the technical side of digital graphics, kind of when it was blossoming there. 3D graphics was kind of the new thing, and I got involved with some of that, but right away I could tell that I didn't really care so much for creating stuff on the computer, more like fixing it and fixing the problems that came up as a result. I'm going to bring up some pictures that I posted on my work website for this. Actually, the reason I know Al is because my wife works at Names and Numbers, and I actually used to work there. I started there right out of college, and that's kind of where I got that idea that, you know, I want to go into networking, I want to do computer repair and that sort of thing. Actually, my focus was computer repair at first, and then it kind of, you know, gradually went into computer networking and troubleshooting. I have a strong background in Macintosh, actually, because of the graphics stuff that I was involved in early on in college. And so a lot of the troubleshooting skills that I had worked well in a school environment. At that time, it was mostly all Macintosh and Apple. And we kind of have gone back to that, you know, with the iPad and all these initiatives have done in schools, but at that time it was also very heavy with Mac. I also worked at a dial-up internet help desk here in town back in 2000, 2001 when it was hot, and just did basic support with them. I really like the school district, and I'll go ahead and get into kind of what I do there. Exactly what I wanted. Of course, with the school district, we've got just this traditional network. There's a couple of things that we need to do, particularly since we have minors there. We have what's called a content filter, which some of you are probably familiar with, but we have to meet SEPA, which is the Child Internet Privacy Act. So by meeting SEPA, we get funding for our school, and it also ensures that people or kids don't see inappropriate images and do things online that they're not supposed to. We have about 10 buildings that I manage here in town. I can show you this map right here. It's not real descriptive on breaking down what buildings we have, but it kind of gives you an idea of how it's laid out, which is kind of looks crazy, but right there in the center is our core router. And then we've got the high school, we've got a middle school, which is, this is all the switches and stuff there. And then we've got 4 grade schools. We've got George Nettles, which is out here. Actually, it's right across the street over there. And the board office, which is our administration office, it's over there as well. Metal Art School's over there on 20th Street. And we've got Lakeside School over by Lakeside, the park. And there's the transportation department out on routes. There's several sites that are all connected with gigabit fiber. We're one of the largest networks in Pittsburg because of the miles that we cover of fiber optic cable. We lease all of our fiber optic cable from Cox here locally. And this is a map that they kind of made up for us. It's wrong, but it kind of shows you all the different sites that are connected. And then we're, it's layer 3 at the central hub there at 13th Street is our data center, which is right there by the Hutchinson Field, you know, the football field there by the middle school on 13th and Broadway. Inside the buildings, all of our buildings here, these white links between the switches, they're all 10 gig backbone, multi-mode fiber. Are you guys pretty familiar with the different types of cabling and stuff like that? I imagine you are, right?
Just very generically.
Okay. I can show you an example here. That was one of the things I brought. A lot of times multi-mode fiber, it'll be orange, like this, and it'll be within buildings, and they're for shorter distance, shorter haul. And single mode, what I'm talking about, it kind of looks the same. It's got a different jacket, but it's got a different internal width on the glass. That's what it looks like. And those are all SC ends. A lot of times you'll see LLC or ST, which is stick and twist, which is an older end as well. Inside the buildings, these are new. This is a 10 gig transceiver. Transceivers are used to take fiber optic. Actually, you know, you can hook up a fiber optic cable, but there's nothing on it. It needs light, basically, to transmit any data. So what these little guys do, these light those fibers, and then that gives you an actual physical link between your switches. This is the kind that we use. It's a 10 gig module. Got a couple of those, but get back over here. So that's kind of the connectivity. This last summer, we put in about 40,000 feet of Cat 6 platinum rated cable in our high school. It's been a major overhaul. The original network in the high school out here on 4th Street was 1 drop per room, and that's all they ever had. It was Cat 5. And so we went ahead and increased that to about 5 drops per room, or in lab situations like 20 to 30 drops per room, some even up to 40 to 50, depending on the room size. But that's why we have that much, 40,000 feet of cable put in there.
What was the cost on that project?
It went over, and usually what we do on a project like that, since I can't do all those myself, so of course we outsource that, and we bid that, and anything over 20,000 has to be bid, basically. Any purchase we make over 10,000 has to be board approval. And that's because we're a public school district. So a lot of the times what I do is I have to justify why we have to do things. And so I do technical writings, but sometimes really I need to dumb it down a lot of times to put it in layman's terms. What will this help us accomplish, basically? And so like in the situation of high school, typically we run on a max move that change type situation, about $100 a drop if we outsource it. Of course, if we do it ourselves, I've got all the equipment to do it. There's no cost other than my salary, but $100 a drop, $80 a drop, really good. In some situations, like at the high school particularly, we had to extract old cable and this non-plenum stuff. Basically, let me explain that a little bit for you. In a typical ceiling, this is talking HVAC stuff, you've got return air that goes above the ceiling. That's called a plenum ceiling. It sucks air out of the room and goes back to the exchange. When it does that, if there's ever a fire, the fumes off of plastic that's burning in that room can get back into the air exchange and go into other rooms, which can kill people. So your PVC, the jackets on cables now, you have to limit how much you put in a building, or you have to get plenum rated cable. That is, the cable itself, when the jacket burns, the fumes that it gives off is not toxic, so that when it goes up into the return and circulates through a burning building, other people in other areas of the building won't get suffocated as a result. In a school, it's pretty important. Hospitals, lots of places like that, you'll run into it. Typical residential, you'll probably never see it. Some businesses, you'll probably never see it, but it's a little bit higher grade cable and jacket.
Considerably more in cost?
I can't remember the last pricing, but what's typical for Cat 5E right now? Just a ranch standard is like $250 a box for 1,000-foot roll.
1,000 foot is about, we had about 200.
I think the last I priced was about $320 for a Cat 6 plenum rated cable. So your costs are going to go up there, your installation costs are going to go up, your jack costs are going to go up. But, you know, it's safer. And to me, though, honestly, it's kind of a joke, really, because you look at a building like Pittsburg High School. It was built in 1978. If you take one of those tiles out, just like you do here, there's stuff above that ceiling. There's PVC condensation lines that go out that are way thicker than that Cat 6 jacket that's going to burn and supposedly cause, you know, these toxic fumes. I don't know. I'm kind of on the fence on it, but you know, for my job, I have to do that to be sure that we don't put anything in there that's too risky, you know, in case there's a fire or something like that. In fact, our middle school out there on Broadway kind of looks like a castle. I guess you guys don't know what I'm talking about out there. That front part was built in 1920, and we reoccupied that a couple years ago. But the city came in and said, you've got to extract all of this cable, because if you leave it in there, it causes this hazard where it burns, creates smoke, go back into the new part. So we had to rip all that cable out just because of the fact that we were going back into that area. We'd gone out, they'd gone through an abatement for asbestos, they'd taken all the bad stuff out, but they didn't go back and get the cable out, so we went and did that. So that was an additional cost we didn't see when we went back in there. But there's a new section on the back that's all brand new, so that's the main part of the building now. Another big project while I've been working there was, of course, Metal Art School. It was built new. They also got a grant for FEMA rooms there to where they have storm-safe classrooms where the shutters will go down on the window, and they've got a whole bunch of security built, you know, thick walls and everything that'll withstand a hurricane. We're looking at that as one of our disaster recovery sites for our data center because of the structure itself has been reinforced. A lot of people think basements are good for data centers, but actually you've got a lot of problems with moisture and water and stuff, and we've kind of gone away from that way of thinking. Lincoln School is another great school we used to take care of. It was over there, they tore it down. It was over on maybe 10th, between 10th and 12th, something like that, on Locust. For a long time, I supported that building as well, and it was later turned into the Family Resource Center. A lot of people I talk to have kids that go to the Family Resource Center, and they do a daycare and that thing. It's connected to the school. We also support the network and all the equipment at Elmakers, which is a youth home out here on Rouse. I forgot to mention those. So like I said, we're a centralized layer 3 network with a single layer 3 switch at the central hub. That's a 5406ZL. And actually, I think I've got a picture of that one. Yeah, here's the switches. That right there is at our high school. If you see that, that's a whole big old massive cable. One of the halls there, 200 halls, 300 halls the same way. That's just a little PoE switch that we have at our transportation department. Transportation is where all the buses co-locate there. They get fueled up, and basically that's not a whole lot of networking needs at that building, but that's what that looks like there. That's one of our grade schools. That's a switch closet at Westside. If you look here in the back, you can see the phone system too. We outsource all support on the phone system. These are pretty old. These are Avaya cards. There's a 5406 right there. You can see the orange fiber uplink. That goes to another portion of the building. The single mode fiber that actually connects the switch back to the hub on 13th Street goes to copper at this point. So you wouldn't be able to see its uplink right here. We've got a DVR system there. All the schools have security systems. There's backup power. There's backup power down there somewhere. And then there's the transformers for the
The DVR, you're talking about digital video recording?
Yeah, sorry about that.
Okay.
Yeah. I use a lot of jargon now, and please stop me if you don't understand it. There's a cable tray over the rack there. That really makes it a lot nicer on your termination. When you bring a bunch of cable into your patch panel there at the top, you can kind of comb it down and bring it into bring it over on that cable tray. You can also do a lot with your loop that way, so that if you got excess cable, you can kind of hide it up there. And then I buy jumpers, like 3-foot or 6-foot Cat 6 jumpers to go from the patch panel down to the switch. That's just pre-terminated cable for like $1, $2, and they've got the ends, they're tested. You don't want to do all this and then plug something in here and it not work at your switch. You can troubleshoot it all day. So that usually is a pretty cost-effective way to go. That's one of the transceivers. That's old. That's actually been replaced up there at the top.
That's pretty.
Yep. That map I showed you, we have 20, 30 of those, just like that, set up in all of our buildings. That's just one wing of our grade school. That's 600 hall of our high school. That's out there kind of on the south side of PHS, southeast side. There's a PoE switch below, and then this is a 5406 ZL. That's kind of my standard switch because it's so flexible. I was trying to get to a point where I could show you kind of a clean picture of that, but you can get fiber optic transceivers plugged in here to give you that flexibility to go switch to switch or switch to hub. And then you've got all this capacity for, these are all 10, 100, 1000 ports. These are all full PoE as well. And this PoE switch, power over Ethernet, powers access points that were already there. So this switch was here first, and then this one was put on top of it. The one that was there before was way old. It was a 100 meg switch.
How many ports are on that switch?
Those are high density ports. So you got 24 on each card module. And then you've got 4 bays on each side. A 5406 is, 06, 6 on the front. So you got 6 times 24. You see, you lose one for the fiber optic port. So, and you can put wireless controllers in there. HP makes a lot of kind of modular. I'm not plugging HP or anything, but they are cheap and they've got lifetime warranty, so it's perfect for a school. But if you care, there's a bunch of modules and redundant power supplies and things that you can put in these switches. They're pretty universal. That form factor, 5406, and then there's a 5412, which is a larger one, and that was actually the cover page. That's nothing. There's just a bunch of different places. There's the big one. You can barely see it with all the patch cables, but that's 300 hall at our high school, which is just one hallway. It's a 5412 under there.
If you don't mind, could you share, that's a layer 3 switch?
Mm-hmm. And this routing is, I got VLAN set up on that.
Okay, so you've got VLANs and so you probably dropped what, about 10 grand on that switch?
18.
18.
You have to pull out. But you compare that to a Cisco model.
Oh yeah, that's half, at least half price.
Right, right. That's what we were looking at. And you know, this is kind of it's not a main closet, it's more of an intermediate closet, kind of tail end. This is the last, this is as far out as we get, you know, to the end user. So basically all it has to have is high density copper ports and a couple of links. Same shot.
Notice you were using APC UPSs?
I really like them. And those particular models there, I think this is kind of bad, but they've been the same for about the last 5 to 8 years. But I tell you what, how much does an AP or does a UPS change?
Right.
It just has to output power and stay up. And those batteries there, I can get still today, and I can pop them in, and they'll support that switch right there. So I think they're 1,500 watt.
Yeah.
That's two 1,500 watt power supplies. So I have basically the power supplies on the back are modular. So one power supply goes to one APC, the other power supply goes to the other APC. You've got redundancy that way.
Absolutely.
So we hardly ever lose that switch. Here's one of the grade schools. Here's how it's kind of, this might give you a little bit clearer picture since it's Visio. This was a plan we drew up when we were replacing the network equipment at Lakeside School. Current was a 4000M, and those weren't high density ports. They took up the same 4U, I think that is. So we kind of showed the justification there, how we could save space but gain capacity. Of course, we could put more fiber ports in there. Same deal, a little bit newer switches. There's a 5412 looking at it straight on. Let's see, 24 times 1, 2, 3, 4, 5, 6, 11, 12, basically you can get in there 256 max. There's kind of that layout I was talking about where we've got our office, technology office. We've got a 1 gig backbone, but through a transceiver. Then we got multi-mode between these nodes. And then you got to think about, okay, you get your access points hanging off of each one of these switches powered over Ethernet. And actually, all these access points, at least we have two controllers. We got two different controllers. We got one set of controllers for G, and we got one set of controllers for N. 802.11N, 802.11G. And we're kind of mixing them now because, you know, you need N, you need G, and backwards compatibility. But at one time we could, and we still do, we have one controller basically central for that G network, and it controls all these access points. And you set up what HP calls WLANs on your router there, and you can set up, they're basically VLANs that set up little networks on these. You can set up different SSIDs. What the point of that is, I'm trying to say, is you don't have to go into each one of these access points and set them up like you do at home or whatever. You basically just tell it, this is my access point, and then it's controlled by a controller, which was kind of a neat thing that came about while I was setting these up.
What are you using for your wireless security?
We've got just straight WPA. The problem is, in an environment like ours where we got so many different sites, we've got people coming in all the time. We need a captive portal to where we can just bring people in, go through a guest. But with that comes a tech support person that's on the phone all the time that someone calls. I can't be called like that, so we'll either need to hire somebody for like a help desk support when we implement, some sort of temporary password code thing. Because what's inevitably going to happen when we do that, when we don't just have the building password, is we're going to have people that can't get on daily. And that's kind of what I've avoided by doing this. There's a building password. We have a person at each site that's there, but they're a lab monitor. They watch their computer lab, and when somebody has a computer problem, they may or may not be able to fix it. Generally, it gets escalated to me anyway. So with that workload, I've not done any, and there's extra packages that you have to buy with HP that we just haven't done. There's an IBM, identity management software, and some other things, but we're just using straight WPA2. So, and it's a building level password. And most of the time, since it's a public school and they're 10-year-old kids, you tell them enter the password, and then they're on the internet. And the other thing we have to deal with too is we've got people coming in from PSU. These are facilities and off hours. We've got people coming in from different state departments that come in all the time. Of course, we're publicly funded, so if a parent comes in and wants to get on the internet, we have to provide them that capability. So that's one of the downsides, I guess I could say about my job is we have to support everything, and everything has to work. We put too high a security level on stuff, we get blocked, or we get problems because people can't get on with certain devices. We do static mapping with Macs at our DHCP server. We use a CentOS 6 Linux server for DHCP. And I just do static mapping. I've looked into doing something like Packet Fence, which is an open source project, to help me manage that a little better. But what it comes down to is 3,000 computers and 200 printers and 300 switches.
And 2 people.
Exactly.
They keep, how big is your staff?
We've got 500 staff.
500 on staff.
We've got 3,000 kids. And actually, in the position we're at, we support the community.
Right.
Because we, like I told you, we support the youth home, we support the daycare that's funded by this public funds, and we also support the public, the parents, all these people. They're in and out of our student information system all day long. You know, just like you guys are hitting Angel and all these different things right now. Is that what you're using?
Yeah, Canvas.
Canvas, yeah, that's it. And by Instructure. I looked into that for us too, but for our size and everything, we get a package called Power School. It works good because the parents can get in there, they can check the kids' grades. Kids are in the room checking the grades just like you guys are, hitting it all day long. So it's pretty taxed, you know, all of our systems, which leads us kind of to our servers. You know, we went the traditional route. I've got mostly Dell servers and Dell rack, Dell everything, this and that. But I got some Dell R610s right now, and we've got a Core-Aid SAN, which is basically gives me the ability to virtualize servers. I can spin up a server inside this SAN using the hardware from this server, like this processor and the RAM, but the hard drive space off of the SAN. You divide that SAN into individual LUNs, and then you map those LUNs to particular servers. Does that make sense to everybody? Sorry.
We've kind of scratched the surface of that just a little bit.
Okay, let me just blow your mind real quick.
Yeah. So how many servers do you have virtually?
30.
Okay.
We probably got 40 servers.
Okay.
Here's kind of the servers right here, all those guys. And then I was telling you about our physical network here that connects up with the router. That's not really what I want to show you though. That's our virtual environment. That exists on 3 servers in one SAN. What that is basically these blue things represent a server. These green things represent a virtual Ethernet NIC. And then these little guys here kind of got the SCSI interface and the disk drive. Those are all basically LUNs or segments of the drive and stuff that all these lines connect that. And so this is what's in my head, but it's also right here. And so, I don't know, just let that soak in for a minute because that's kind of where it's going with server management. You don't build up one server anymore. You tank out one big server, and then you get software to divide up those resources and build virtual servers inside it. Well, I mean, a lot of these things, we've got a lot of services tied to that. So, of course, the other thing I want to talk about, and I want to make sure I talk about, is this SAN we're talking about here is about 8 terabytes. We purchased 20 terabyte SAN, just purchased it, have not received it yet. Some of these pieces here are for it. This is a twin-ax cable. You guys know what that is? Twin-ax, this is 10 gig twin-ax. Instead of buying the transceivers and fiber optic cable like we talked about, putting in your HBAs in the back of the server, you basically buy this card, something like this, a 10 gig card. This is going to be all of my Ethernet interfaces aggregated over 10 gig. Rather than buying a transceiver for both ends, which is like $1,000, this is a $300 cable that has a molded on. It's called twin-ax. I'll look it up on Wikipedia. Give me that card too. I mean, it's not much different than fiber channel or some of the stuff you probably messed with before, but that's kind of the new thing. And it's cheaper. So
Cheaper than fiber, that's for sure.
Oh yeah, yeah. I mean, I can get those jumpers for like $25, but the transceivers are the cost.
Right.
You've got to keep this thing lit.
And power.
And there's compatibility issues. I can have one transceiver on one end that doesn't talk to the other. I can have that transceiver that doesn't work in that chassis. This thing kind of takes the guesswork out. I don't know who makes those. I think that's an HP product too.
That's what we're using on our Dell SAN.
Mm-hmm. Yeah, you've got a, let's see, that'd be called Ecologics.
Right.
I don't know. Twin-ax cabling, twin-axial. I'll show a picture of it. I don't know what this is. Doesn't look like it's not. You can look it up if you care, but it's pretty cool stuff. Oh, the servers. Yeah, I told you we've got like 30 virtual servers on that right now. We're going to migrate that to a NetApp SAN. Let me show you some of that hardware real quick. If you're not familiar with what a SAN even looks like, I've got a picture of it up. Shoot, something other hardware here.
Well, they actually saw some of the hardware already over at Names.
Oh, cool. Okay.
So they've got some point of reference.
This is nothing exciting here. That's just another connection for multi-mode fiber. People kind of standardize on that SFP and LC style, which is that smaller form factor. For that, which is what I'm dealing with like in high school stuff, we have terminations that are ST, which is stick and twist. So we encounter that quite a bit. A lot of times I'll just buy, again, fiber jumpers to go from that end to SC or LC, whatever style I need to. So that's not generally too much of a problem if you run into that.
You terminate your own fiber?
No, and I was going to talk about that. I have a kit to clean it, but I would never terminate my own because you have to buy an OTDR and all this special equipment. And for us, it's more effective if we outsource it. I've looked at doing it myself, but not to discourage anybody, I think it's a dying art form because I can call up any supplier and get preterm fiber for the same cost as by the foot.
Yeah.
So, but it's definitely a good thing to get into because you're the guy that gets called at midnight for $300 an hour or whatever to go fix a fiber splice somewhere because you'll still always need that. But for inside of buildings and stuff, like if I want 800 foot to go from this end of the hall to the other, I buy a preterm fiber, it's like $1 a foot.
Yeah.
And preterming, pre-terminated, done in a factory, just kind of like I was talking about buying those Cat 6 cable jumpers. Yeah, pre-made. I do it, you have to do it, you got to know the skill because you're going to use it. But when you can and when you don't have time, you buy that stuff to know that it's done right, first of all, and that you won't have any problem. But there's that, I think that's the core aid SAN that we have. Yeah, that's what that's supposed to be. And basically it's just a stack of discs, and it's got controllers in there. Al said you guys already talked about one. That's kind of the new one we're looking at. You don't really see the discs on this one because they don't remove the panel, but inside there, up and down instead of linearly, if you look at the difference, and anybody will be able to tell this, but those are 3.5-inch discs, and you can see your density. You got 1, 2, 3, 4, 5, 6, 5, 4, 24 discs, 3.5-inch, 4, maybe 5U, 2U, 24 discs, 2.5-inch. And you think, okay, well, 2.5-inch drives, those are laptop drives, right? But they're kind of at the point now where they've got a high enough RPM, and you can get SAS. You can get SATA if you want, but SAS is kind of your server level enterprise drive. So, well, we got SAS drives, 900 gig, 24 discs upright in there, 2U. So when you expand, you're not using so much rack space, you're not generating so much heat. Just the natural comparison between 2.5-inch drives and 3.5-inch drives.
Yeah.
So.
Dallas mentioned something there called a U, 2U, 5U, 7U. They're talking, what he's talking about is the width, or not so much the width, the height of the particular device as it sits in the rack. The rack is a standard width. And so when you start talking about 2U, 4U, 5U, that's increasing in the height.
It's important anywhere you go. It's more important in the business world because a lot of times with people outsourcing and doing cloud-based or renting rack space or whatever, you're going to want to get the maximum amount of U space that you rent, or the maximum amount of either storage or processing power squeezed into that U. And for us right now, it's not so much an issue. We own our own property. We have our own data center. We have our own racks, our own power, our own cooling. But as we expand into bigger arrays of these SANs, it's going to become an issue. You never want, all this equipment, spread out everywhere. So whenever you consolidate, it's pretty good. But there's basically 2 cards in here. They've got the 10 gig port on the back. We use that twin-ax cable. It's going to go into that card, and it's going to plug into our servers. Everything's going to get migrated over, and I won't have any headaches. This is an HP MSM 430. That's one of the standardized light access points that we use for G. MSM 430. And the controller for that's on that sheet. It's a MSM 765. Those are just specific model numbers that don't That's what that controller looks like that I was talking about. It occupies that whole module bay and one of those switches I was kind of showing you before. That controller has like onboard SSD. It's basically just a little computer with an OS on it. And it sits there and it'll do your radius authentication and do all that stuff. But basically I just use it to build virtual networks on. I just threw that in there because that's a Cisco Unified Chassis System, Cisco UCS. Have you guys ever heard of that?
No, we haven't discussed that.
It's pretty cool. It's, you know, like we were talking about servers and virtualization and plugging servers into a SAN. This is kind of the next step, and we're not quite ready for this, but in big data centers, this is what they're putting in, Unified Chassis System. Basically, those are blade servers. That's one server that goes into a chassis. You don't even plug anything in. The network is on the back plane. Your SAN is on board. It's just all one unit. So server administration's kind of become more unitized, I guess. What's the word?
Well, basically what they've done is they've modularized.
Yeah.
A lot of the standardized components. Like for example, the server's on a car. Boom, you need a server, pop it in there. If you need a switch, you can pop a module in there. If you need a router, you can pop it in here. The idea is to consolidate, standardize everything so that you've got the flexibility if you need additional servers, if you need additional switches or what have you. You've got one box that you can deal with. There's pros and cons about it. It's still evolving. I tend to think that it'll reach a point where economics is going to kick in. Right now, it's a nice flashy toy.
Right.
But
And that's kind of how we saw it too. It's nice to go that route, but then you're paying all your money to Cisco. You're paying all your money to EMC or whoever makes this box because you can't turn around without buying their product.
And it becomes proprietary.
Yeah,
And then you start getting into all kinds of other issues,
Yep.
like licensing.
Yep.
Cisco is notorious for having maintenance agreements and maintenance or licensing in such a way where you have to renew it every year.
Yep.
Where you have companies like, for example, HP, where you buy it, it's got a set warranty over a period of time
Well,
built into the price.
Lifetime warranty on none of these.
But there's also some caveats to that.
Let me tell you one trick I did. When I first started, we had a lot of 10-base hubs sitting around, and some of them were burned out ports. So I sent them into HP, and they sent me 100 meg hubs.
There you go.
See, I mean, you can't beat that. I mean, yeah, it's a 100 meg hub, but that was 5-6 years ago.
Right.
So that's all we needed at the time. And you know, now we buy switches that are centralized. They know that. If you've got a big network, you're not going to buy a whole bunch of these little hubs or try to you know send in old equipment because it's I mean, economically, like I say, it's not going to work for you. You have to buy a big switch down the road at some point, and they know that. So, yeah, they give you a lifetime warranty, and I don't know that they really EOL anything though. So you call them when you've got the ProCurve lifetime warranty on. I call for really old stuff.
Yeah, they're usually pretty good about that, but you know, companies like Cisco, and there's several other ones out there. It's kind of like in the printer business, right? You go out and buy a printer for $50, right? But the ink costs you $100. So it becomes advantageous to really start comparing, especially brands and performance and quality and so forth. Something like what I call bleeding edge technology, these particular devices, I have a tendency to shy away from them because they're bleeding edge. There's things in there that they've never engineered for or considered. They put it out there, and then you're paying for that research and development, or I should say field testing.
It sounds like counterproductive. It sounds like you're holding the technology back, but you're actually saving your job in a way too.
Well,
you know.
Yeah, it's more important to have the system up and running and reliable than to be real fast and have to stop.
And not know how to back out of that or how to get your data back out.
Exactly. Now, there's some companies, for example, Walmart, that is what they pride themselves on, bleeding edge. They're always out there so far ahead. And companies like Cisco and IBM and other manufacturers, they gravitate to that not only for a possible revenue stream, but they also gravitate to that because, well, these guys are really willing to take some risks and really field test our equipment so we can learn and improve. So there's a symbiotic relationship there. But the thing to remember, like Dallas is saying here, there's a point when you have to measure how much of a leading edge, bleeding edge, or trail behind do I need to be. And reliability sometimes is what you are sacrificing by going the bleeding edge route.
You gotta look at costs, budgets, things like that. Fortunately, I don't have to mess with that as much. My boss is technology director, so he gets to present a lot of this stuff to the board. I don't get in front of people and tell them all this. I give him and fill his head full of all this technical garbage, and then he translates it to the public for me. So that's a good relationship there. I'm not just HP biased. I also have some Juniper equipment. This is an SSG 140, which is probably about 5 years old. We're looking to replace it. It's a firewall, is all it is. Pretty simple. Ports, IPs. It does have a GUI. It's it's got a web administration, so it makes it somewhat easy to create policies for IPX to go to IPY. So there's kind of the back of it. I don't have any of those cards. Those are mostly T1 cards, ISDN. I plug in the front on all mine. I've got port 1's the trust port internal side, port 2's the untrust external side, which goes to your, well, in my case, our site router provided by our ISP. I've got another port hanging off of that. It's called the DMZ, and the demilitarization zone is outside the firewall, but it's used for specific purposes.
And when you want to put a server out and expose it completely out to the outside world, and that's one way of doing it, and still be able to control, if necessary, what goes into and out of it.
A lot of times I find myself using that in a situation where I have to prove something to a company. They say, oh, you've got a firewall or something blocking that. I'm like, okay, let me put this out in my DMZ. Can you see this port? Can you see this port? Yeah, try it now. Okay, it doesn't work. Well, obviously it's your software problem. So
Yeah.
you can kind of be a smart ass like that, I guess. But
that's hard to believe. Now, what are you replacing your firewall with?
we're looking at Palo Alto. Have you heard Palo Alto now?
Yeah, I have. It's relatively new.
Yeah, it is new. That's why we've drug our feet since May on it. And we've drug our feet enough that they came out with a new model and dropped the price. So
Well, that's two good things, yeah.
we're on the right track.
We're on the right track.
Yeah, we tested it in May. I've still got support with this Juniper, which is important to me.
Yes.
5 years is a long time to go. This is still running Screen OS 6. If you talk to anybody that does anything with Juniper, they're running JuneOS, and that's not what this runs. But JuneOS is a lot more like Cisco routers and switches. As far as a firewall, it's a simple device to me. It needs to be simple. It needs to work. This has worked well, and the support was pretty cheap. I think it's $1,000 a year or something like that.
Okay, you got another 10 years of life in it.
I really do. But here's the problem, and I'll go off on a tangent on this too. Firewalls are kind of like base level right now. What this box does, I could do on any old server, really, anything. This has probably got a 48, 80 gig hard drive and a 1.2 gigahertz processor. You don't buy hardware specs in a firewall. You buy software and features. And what this does is just basic firewall ports and IP stuff. And what kind of I'm learning with this Palo Alto box that we trialed, that's not where things are anymore. I used to be able to go to my firewall or go to a content filter and see what sites people were actually going to. When they hit www.whatever.com, it came through and said they were going to whatever.com. It doesn't work that way anymore. What has happened to the internet is there's this collection of content delivery networks. And YouTube's got one, Facebook's got one, there's big ones like Level 3, Akamai. That's where our traffic is coming from. The internet and people on it right now are just transitioning to this consumer thing, this consumerism, where we're all just consumers of giant clouds of data. So if I get a YouTube video and download it to my computer, it's already cached on this content delivery network node, a couple hops away from me. At some data center at Cox, probably. Cox probably has a content delivery agreement with YouTube and several of these other places that people get a lot of traffic, or people send a lot of traffic, or request a lot of traffic from, excuse me. So what that does to us, in a school environment at least, is because we have to filter all this stuff. We can't determine what's coming from that content delivery network. It's not a simple request, HTTP request, a GET from site A. It's a request to content delivery X, and we don't know what's really coming into that. So what we're looking at is deep packet inspection. We're doing some of these things on Palo Alto. They've got proprietary, again, I don't know what to call them, signatures, I think is what they're called. But basically, when I open up BitTorrent, for example, it can pick, and you guys all know this, it can pick whatever port isn't blocked. It can use web. It can get on whatever port to get out to another server. At one time, programs used to play by the rules. HTTP was always on port 80. FTP was always on port 21. Mail was always port 20. Telnet, or maybe that's Telnet, it's 22, 20, I can't remember. I don't pay attention to it anymore because it doesn't matter.
Right now, it's a starting point.
Yeah, but it's really irrelevant because a lot of times, and everyone knows this, the only thing opens 80. You look at your internet connection at home from whatever it is, we'll say Cox, they're blocking remote desktop, they're blocking port 80, they're blocking all this stuff because they don't want you hosting anything there. Well, and the software has adapted so that you can actually get around that now. And that's what, we're trying to block as a school. Like I said, we can't let the kids download this stuff on BitTorrent. We can't let them go to bad websites. So we need, what the Palo Alto box does, and again, it sounds like a sales pitch, but I mean, it really, it has proprietary signatures built that show us what that traffic looks like deep on the packet level, rather than where it's coming from as a source. Because it can come from any source now. People bounce stuff off of all kinds of nodes.
So essentially what you're looking at then is no longer a layer 3 device, you're looking at a layer 4 device.
I guess.
Yeah, absolutely, yeah.
Yep. There's definitely some things out there now that we really need to move towards. This firewall doesn't cut it anymore. And content filter is kind of more of a software thing. But what the Palo Alto firewall does is it blends the software and that hardware firewall so that we have some, when you have separate devices, that's kind of the problem. You're looking at your firewall and see that as a problem. How come I can't get out? Okay, I opened it at the firewall. Well, now my content filter blocks it because it sees it as a Facebook login or something. That's why you're getting blocked at this particular site. So when you combine it all into one device, you kind of get a little more visibility as to what's going on. And, I kind of go both ways on that. A lot of times I'm combining functions on devices, and other times in high traffic areas, I'm dividing up the functions or the roles of devices. Like, for example, with our Power School student information, I mean, we're talking about putting one out there to same host of data that the public hits and leaving one on the inside. So instead of just one central server for Power School information, we start, dividing that out. But like I said, in other situations, we're rolling things together. So
by splitting those two, though, and I assume you're doing some type of mirroring or
well, there's an Oracle database.
Okay, so
and so we could tie to the Oracle database. We could actually, again, maybe we have an Oracle server that only hosts Oracle databases, and then we have another, which in Power School, in this instance, it's a web server basically that you interface with. So that's the thing getting hit. So that's the thing we want to divvy up. We want to say that's the public-facing web, this is the private-facing web.
Right.
They talk to the same Oracle server so that your data is the same, but the requests from both sides of that are handled differently.
But and also too, you're gonna increase your survivability in the event you get attacked or
Right.
or some other catastrophic event happens.
Right. And that's kind of, you can't, the server's down, you get that call every once in a while, like, oh, really? The server's down.
It's working.
Well, which server is it? Which service is failing on these servers? I mean, I have DHCP servers that's all they do. They run the DHCP service, that's it. 2 DNS servers, that's all they do. They run DNS, they do lookups for everything all day long. On those sorts of services, you have to kind of divvy them up depending upon how much load they've got. I think there's anything more interesting here. There's a Cisco ONS Sonnet ring. That's what's used by our ISP, well, actually by our fiber provider. Let me explain that a little bit. What I showed you here was just our fiber links. These are leased, we don't own them because we can't own the city. So Cox owns the lines that go throughout the city because they have an agreement to do that. And we pay Cox for the access to those fiber optic lines. We don't pay Cox for internet like you guys do at home or anybody else. We buy bandwidth from Canron, which is a research and educational network set up for schools, which Pitt State's also a part of. So we buy bandwidth. It's through a consortium. You pay a membership fee and you get, actually our school, we have 100 megs of bandwidth that we split up between all of our schools.
Yeah.
Yep. This is a typical classroom, and I've talked about the network side of it, but there's a lot more that goes on in the school than just what's behind the scenes. That's a smart board. You've probably seen those. These are all of our classrooms have a projector, a smart board or a projector screen, a sound system, and I don't think you can really see that in this picture, but it's a document camera. They call it Elmo is the brand. This is actually a better picture. This is in one of our grade schools. You can see the mounted projector. You can see these. Those are not air conditioner vents. Those are 10-inch surround sound. That's the sound system for this teacher. Most of the grade schools have sound systems actually. That's the smart board mounted because they have to be calibrated if you ever move them because you're touching things on there. So it has to match up with your movement. Like if you have a computer, like if that was my smart board, I could move that mouse. Like that. So it has to stay mounted. So that's kind of a pain. So we have to, if the teacher changes their mind and they want to teach from over here, we got to move it. So, but we've got that all surface mounted, VGA, audio cables. There's the document camera. It's got its own built-in splitter. So it goes to the feed on this computer and then it goes out to here. So you can switch between, I want to show this on the projector, I want to show my screen on the projector, etc. Most of our classrooms have this little mini lab set up. This one actually has 5. Usually they have 4, some of them have 6. Some of them have a printer on the end. It just depends.
Are your projectors hooked up to the network to identify if there's some kind of a problem? In other words, is it like
tell you when the lamp's low or something
right,
like that?
exactly.
No, the ones that we got were through a grant, so we had to keep it kind of cost effective.
Okay.
These are less than like $800 projectors.
Right.
They're not network, enabled or anything like that. But like I said, we've got one person at each site, and that's kind of their job, just to keep up on that kind of stuff and watch the lab. This is actually one of the labs at our grade school.
Okay.
One of our grade schools, Meadowlark Grade School. We've got a color printer in there. We've got a laser printer, color laser, regular black and white laser. We got a scanner. We got a PC, flat screen, some other stuff. These are all Lenovo Think Centers. They're all hardwired. You think, oh well, wireless would be the way to go. Well, not on a lab. No, the amount of cable coming through this is probably about 8 inches and 10 inches in diameter coming out each side of it. Well, the two sides, when they come together, you got a pretty good water cable. That TV's pretty old, but you can see the projector screen. There's a sound system in that room as well, obviously. Typically the labs are about 30 computers. At an average grade school, there's 5 computer labs, maybe more. Lakeside has a lot, high school has a lot, middle school has a lot of labs like this. And then we got mobile labs. We've got big carts that you charge laptops on. We roll them into the classroom. I don't know what else I want to show on that, but that's kind of just, there's a lot of things going on. We got iPad, hundreds of iPads, iPods, all kinds of.
How do you maintain your inventory?
Right now we've got a spreadsheet. Well, it's actually a FileMaker database, but we have the people at each site, so they scan it with they get a barcode scanner, and they can scan the barcode, and they bring it in. I set up just a, what do you call it? Just on the entry page of the FileMaker where they can just boom, boom, boom when bringing it in.
Well, what about the software inventory on the machines themselves? Do you have any kind of?
We don't do any desktop management software. No. We are looking at that, but in something our size, you're talking 60 grand or something like that. 3,000 desktops. A lot of the software packages we looked at that do complete desktop management around the $100, $200 range. Does that sound about right?
Yeah.
It's kind of one of those things, yeah, we could phase in, but once you use something like that, you really want to use it on all your machines. So we haven't phased anything like that. And then when you go with one, it's hard to back out. We've talked to a lot of schools about that. One school out west we talked to is using Kaseya. What's that?
I'm not familiar with that.
Well, a lot of them are built on the old Novell kind of network stuff, and people moved up through that system, and that's where I get into that. That's where I get into that thing about you get that vendor lock-in. Because once you standardize on that, you're not going to make a $60,000 purchase for your desktop management software every year. You know, you're going to pay the renewal fee, and that's maybe it. But on the Mac side, of course, we use Apple Remote Desktop, which was great. Also on the iPads, we use System Profiler, which is built into macOS Server, which is kind of going away. But that's just for those kind of management things. But in Windows, we use Group Policy, Active Directory stuff. That's always push out our printers.
Right.
We do, packaging MSI and send it to this particular organizational unit. And there's ways of doing it, kind of with what tools you have available, and that's kind of where I've come in too. A lot of times, like for our help desk, I've taken open source software and just used stuff like that. You can make use and leverage some of that free stuff that's out there, but what you don't pay for, you pay for in time.
Yeah, exactly.
And you have learning how that stuff works, and really, it's an investment. And with open source software, a lot of times it runs on Linux, and if you're a super